And we're finally down to the last demographic profile element, and that is aging. Some of these aging techniques are based on things that we've already learned, like this one right here, epiphyseal union. We talked about the epiphysis, the diaphysis. We talked about all that a long time ago when we were talking about the bone growth, bone biology. So you've already had a little bit of a taste of what this kind of stuff is. And actually, it may be that some of these images here you've already seen before. But epiphyseal union is one of those things that we use to differentiate an adult from a subadult, right? So most of these epiphyseal union events have a reasonable, I'd say, time scale, a short or narrow time scale, meaning a couple of years, 2 years, 3 years between kind of the extremes of what we see in development, somewhere between 12 and 14, somewhere between 17 and 20. So it's reasonably narrow, but it's also, it can be quite wide. And so if we look at, for the humerus here, I use just the proximal end because what we know is that the timing of union differs depending on which bone we're talking about and which part of the bone we're talking about. So if we're talking about the distal end or the proximal end of something. So I have the proximal humerus here, and you can see the age is somewhere between 10 and 15 when we start seeing that union take place. So that's a big, broad time frame, 5 year span. It's not great, but it's better than nothing. And one of the other things that's really important is not just that time frame, but really separating the subadult category, being a child, from the adult category. So that's also another very important one. And also, if you have all of your bones totally fused, the clavicle being the last one to completely fuse, the medial aspect of the clavicle, last one, it could be all the way up to the age of 30 or more, which, by the way, you can also see in the innominate down here. I mean, we have this area here, the pubic symphysis, going up to 27, maybe a little bit more. So some of these things last for quite some time. But anyway, so the medial aspect of the clavicle being the last. So if we see fusion of that, we can say, well, we know that this individual is at least this old, and be reasonably accurate in that just by saying probably older than that point. The issue comes into, do we have a range we're looking for? Do we need to know, are they around 20 to 22 years of age? It's like, okay, that's not going to work for us. As far as epiphyseal union, we're going to be able to tell you somewhere between, depending on how many bones we have at our disposal, persons between 20 and 30 years of age, or somewhere between 15 and 25 years of age. We're going to be able to give you that kind of range. We're not going to be able to narrow it down much more than that, just because there's so much variability when it comes to epiphyseal union. But it doesn't matter. The point is, we can use that as an indicator of growth. Once they're fully formed, though, you can't do anything beyond that, right? So if a bone fully forms at the age of 20, you can't say anything beyond that. As far as if that's the bone you have in your hand, you can't say anything further about their age based on development, growth, right? Because once epiphyseal union occurs, the bone is a whole bone. Whether you're 30, whether you're 60, whether you're 80, it's all the same. Now, we're going to look for other things, of course. If you're 80, we're going to see some degenerative issues. We're going to have some osteoarthritis or something like that that's going to indicate you're not 30, you're 80, something like that. But as far as knowing the minimum age, once it becomes fully formed, we can say that, but we can't say anything further. So we need something that can take us further than just that terminal point of growth, which is about, again, depending on what body parts you have. If you have the whole skeleton, somewhere probably around 30. That would be about the extent of what you could say as far as the age of this individual. So it's only informative up to a certain point. And then we have to transition into something else. We have to come up with some degenerative issues, right? So now we're looking for things breaking down, things getting worn down, that kind of stuff. So we will get to that here in 1 second. If we're talking about the growth setup, if we're talking about aging based on growth, based on development, right here, this is by far your best strategy. This is your best technique right here, and that is dental development and eruption, right? Teeth are incredibly highly genetically controlled because without teeth, you don't eat, you die. So teeth will come in on a very predictable schedule. And that schedule is quite narrow. So let's look at this chart over here. Okay. So let's look at this tooth eruption chart. If we look over on this side, let's just say we're talking about the central incisors here. As far as when they come in when you're a wee little thing, I'm talking a 4-month difference. That's it. I mean, those teeth come in within a 4-month span. That's kind of the extreme, one into the other end. I mean, it is crazy predictable when that's going to come in. Look at the permanent central incisors, 6 to 7. Is there variability? Well, sure. My daughter got her central incisors when she was like 4. So there is variability in this, but for the most part, these kids, they're all landing right in these narrow ranges. And you can just look as you go down, even when you get down to like the second molar. I'm just throwing this out. So now you're down to like the second molar. I mean, look at that, permanent, somewhere between 10 and 12. So epiphyseal union can get you into a position where you have 15 to 20 or something like that. You have this big range. You get into the dental work, and now you're literally getting kids. You're being able to identify children through this process down to within months. You could say that this individual that's sitting in front of me is somewhere between 5.5 and 6.5 years of age, and probably be reasonably accurate in doing so. And more so, this would be the forensic odontologist that would be doing all this. But it doesn't matter. The point is, we would be able to nail this age down to a very, very narrow scale. That's fantastic. But dental development and eruption only occurs up to the age of about 18. Somewhere around 18, 19, that's when you get your last permanent tooth. So that would be the third molar. Now the third molar can come in all the way up to the age of 30. So the third molar isn't the best molar to be looking at because it has the biggest range of timing when it erupts. The other ones are much more controlled in how long it takes for them to erupt or what age it takes. So leaving the third molars out because it's too highly variable, you get all the way up through that second molar. So that's what we call the 12-year-old molar. So somewhere around 12 to 15, you're probably going to be able to nail it within literally a year, maybe even down to a matter of months. Start heading out to the 18 range if you have the third molar. Most likely then that you're at least 18 years of age, 17, 18 years of age. But if we don't see that third molar, yeah, that's variable now. Now you can be 17, you could be 20, you could be 22. It's possible you don't get the third molar at all, which happens in a number of people. So that's going to be a questionable time period. But the teeth can easily get you up to 16 and be dead on accurate. I mean, so close as to narrow that missing persons database to a fine point, right? We're going to narrow it down to like 3 people, 2 people, maybe even 1 person, because that age range is so narrow. You go back to epiphyseal union or one of those other ones, and some that we'll talk about, you might be getting 10-year gaps. So it's like, all right, well, you narrow it down, but now you have to, everybody within that 10-year gap gets included in the breakdown of that database. So then you get a lot more people. But then, of course, we're going to tell them the sex. We're going to tell them the ancestry to the best of our ability. So they're going to whittle it down that way as well. But if we're talking about just dentition or past that point, we're going to use epiphyseal union or one of those. It's going to be in those early developmental years. We're going to be able to nail this. Go beyond that, and it's going to be much more challenging because now, after the teeth are done erupting, they're all done. The bones are all done growing. Epiphyseal union has taken place across the body. we're pretty much done right there. I mean, that's about as far as we can go where we have a reasonable range, where it's a tight enough range that we can really do something positive here. Once we get past that, now we're looking for that degenerative type stuff, the arthritis and things, areas that are worn down. The timing in which these things occur, the ranges start to grow. They start to get bigger and bigger because there's a lot of variability in how people, treat their body. Some people are highly aggressive, very active. Their bones are going to wear down. These surfaces that are, rubbing on each other, they're going to wear down. The cartilage between these joints is going to wear down, and then it's going to be bone on bone, and you're going to start getting a bunch of osteoarthritis. So, I mean, those are people that really work hard. They could be young and still have osteoarthritis, or kind of the beginnings of it, and be 40. You could also be 80 and be exhibiting very little osteoarthritis. So once we get to the degenerative stuff, it becomes a lot harder to narrow it down, to really give a tight range. But when it comes to dentition, and I would say also epiphyseal union, lesser so, but still in good shape, as long as we're in that boat, we're going to be great at doing some really narrow scale aging. Get past this though, and it's just going to start falling apart. But we still have to do it. We have to do the best we can. We have to come up with an age. They ask us, what is this individual's age? We're going to give them a range, of course. We're not going to say that this person is 20. We're going to give them a range, but we have to give them something. So even if the range is huge, it's better than nothing, right? If you say 30 to 50, it's like, okay, well, that kind of sucks. That's not really informative, but it is, because it eliminates people before 30 or younger than 30. It eliminates people over 50. So at least it does that. So we're going to do our best to give them an age outside of the development level. It's going to be a little hairy out there, but we're going to do the best that we can. And this would be one of those areas that we're talking about where we see that wearing down of the bone that gives us an indication if they're younger or if they're older. This is the best area. There are two areas that we can look at. I'm not going to have you do the second one because it's kind of hard to do. All of these photos that we're seeing, they're my photos for the most part, and the examples, so like what you see on the screen, these I took a picture of again on that speaker. But anyway, the point is, the other one that would be a great indicator, just as the pubic symphysis is the sternal ends of the ribs. But I don't really have any good examples of that, so I couldn't use that for our purposes here. So I stayed with just the pubic symphysis. But people would say that if you're going to get beyond the growth and development point, right? So the dental eruption, dental development, get past the epiphyseal union, you get past all those, the best place to look or to assess age is right here. It is the pubic symphysis. It seems to wear down in a very predictable way and within a reasonable age range as we go from one stage to the next. So stage 1 through stage 6, and we have everything in between. I just gave you the two extreme examples right here. What we do see in early younger individuals is we see these ridges, right? These bony ridges going across that pubic symphysis. Very, as I put, billowy. It's rough to the touch. It's rough looking. As you can see, it's just a bunch of mountain ranges in essence going across there. As time goes on, that surface will slowly flatten out. A lot of these ridges will start to go away, and you'll get to the point where the symphysial face there is essentially flat, I would say. I mean, it gets to the point of being flat, but then you go beyond that, and now it starts to become concaved. So what we see down here, and it's hard probably in this picture, but there's actually a bony ridge. I don't know if it's really observable too much to you, but there's a bony ridge around the outside, and this area is actually concaved. It's concaved, and so it goes from being externally very billowy, very rough, to flat. You don't see the mountains anymore, and then to concave. And if you really go to the next level, go off the chart of stage 6, that's the last stage right there, stage 6. So if we go beyond stage 6, you really can't go beyond, but I'm talking about the older, very end of stage 6. The face actually becomes deteriorated all along the edges, and so you don't even see a nice edge on this, which you can see here. It becomes just gnarled up all over the place. It becomes a mess. So that's what we're looking for, is that bumpy, billowy, rough look down to the flat look, down to the concave look, and all of a sudden we go to that just gnarred up, irregular area all the way around the irregular border. So if we look over on the other side, you can see that we have the average age, but then we also have the standard deviation, right? Or standard error, depending on what you're looking at. So if we look at stage 1, right, or phase 1, we have an average age of about 20 years. Standard deviation is 2. So basically what you're saying, with 95% confidence, the individual is aged somewhere between, let's say, 18 and 22, somewhere around in there, because we're going to talk about a standard deviation as in a plus minus number. So we're talking like 18 to 22 years. That's fantastic. Stage 2, again, got a number, got a tight standard deviation. But you can see as you go along, the standard deviations get bigger and bigger. So, we're talking 64 years of age here, minus, let's say, 14. So the individual is somewhere between 50, or with 95% confidence, is somewhere between 50, and if we add 64 plus 14, what are we, 78? So the person is between 50 and 78 years of age, somewhere around in there. So that's a huge number, right? That's not nearly as informative as we would like it to be, but isn't that better than nothing? Isn't the idea of saying the person's 50 to 7, or is somewhere probably most likely between 50 and 78, isn't that better than nothing? I mean, at least you can discount people probably younger than 50, right? You could probably discount those people, so that's a good thing. Over 78, let's be honest, there probably aren't going to be that many people out there, so who cares about the 78? Even though we capped it, and there could be people beyond that we would cut off, honestly, it doesn't really matter at that point, so we don't have to worry about that. But at least being able to say something about maybe this 50-year-old cutoff, so less than 50 or older than 50, that's kind of what you might be able to say, and that's better than nothing. So as we get from stage 1 all the way back down to stage 6, our accuracy is going to get worse and worse and worse, and a lot of this has to do with the fact that the bone is wearing down, and it depends now on lifestyle. Certain lifestyles are going to cause this to happen a lot quicker than others. So that's why as you move from stage 1 down to stage 6, that standard deviation gets bigger and bigger, because it's including activity. It's including the life somebody has, the life they've chosen, whatever it is, their occupation, their recreational activities, whatever it is. And then there's also just simply the genetic components of this. Some people just wear down quicker. We know that. Some people get osteoarthritis when they're young, and other people, it's not until they're 80 that they see it. So that's a totally different beast right there as well. So if we're going to talk about the best place to look for aging outside of the developmental areas, the teeth and epiphyseal union, it's right here, the pubic symphysis. The other one, as I said, was the sternal ends of the ribs. Can't show you that, not going to be able to use that here, but that would also be a very good place to look. And the last thing we're going to talk about, so I only have a few things here on aging, simply because I don't have a lot of my materials here at my house. I wasn't able to get them. So a lot of this stuff is going to have to be based on materials that I have. But anyway, so we're only going to do a few aging things here. Here's another one that this now is in the skull. Some people suggest we could use the wearing down of the teeth. So you'll see aging charts for, if the enamel is gone, we see the exposure of the dentin, the yellow part underneath. If we go further and we see the exposure, of the pulp chamber that's inside, right? The hollow cavity that's inside of a tooth. If we see the exposure of that, then they're probably this age. Problem with that kind of stuff is people's diet makes a big difference in how their teeth wear down, the timing. So it's a very kind of questionable, it's it's not very accurate, though it's better than nothing. It's not very accurate. But I go back up to the skull. So we have those teeth wearing down, right? Dental attrition. We could do that. I'm not going to show you that here, but we could do that. But this is probably the one that people are going to look at more so right away if we have the ability, because this here is not necessarily going to be impacted by lifestyle choices, by diet and all that kind of stuff. This is not going to be affected by that. It will be affected by genetics and just simply the aging process, but it's not going to be affected by those other things. So dental attrition may be reasonable for giving us at least somewhat of a range, but this will avoid all that altogether. The idea of suture closure. So if we think about all of our sutures that we've learned, the coronal suture, the sagittal suture, the lambdoidal, all of those things. So if we look at those, we can see what takes place through time. All the stuff that you saw in class, for the most part, it looked more like this. It looked more like zipper stuff. You could actually see all the sutures. As it goes along, you could see it all, right? It's blatant. If I had some older stuff, you may have seen something more like this, where you see some of the suture still present, right? You still see some of it there, but you notice most of it's gone, right? Up here, you see a little bit here, but otherwise it's gone. You look over here and you don't see anything going on over there. So what happens through time is we end up getting these cranial bones fusing to one another. They are open. You can take the bones apart kind of theoretically when you're younger, but as you age, they start to fuse. Why? I don't know, but they do. They start to fuse, and eventually your skull will be kind of just one giant single bone, if you will, at least like the neurocranium will be a solid bone. The spleniocranium, we have fusion there as well, but I won't say the entire skull becomes one bone, but certainly we could say, just for our example here, we could definitely say the neurocranium is going to be essentially one bone. Now, look at your ranges. Okay, look at your ranges. So if we're looking up here, so we're going to look at the sagittal suture. Okay, along each suture, there is going to be a different time frame in which that area, these different areas, are fusing. So it's not that a whole suture will fuse all at the same time, meaning at the, you're starting to fuse on the sagittal suture up toward the point where it meets the coronal suture. Let's say you have a time of that area right there of 40 to 50 years, which if you look here, you notice that's pretty much what it is, 40 to 50 years. As you move away, it's not that if you go back here toward the area where it touches or meets up with the lambdoidal suture down here, you're not going to get the 40 to 50 necessarily. In this case, you're getting the 30 to 40. So it's not that you're looking at the entire suture. You have to look at certain areas of the suture. Those will all have different times. And you can see that if you look on, the coronal suture here is pretty good. 40 to 50, 50 to 60, 50 to 60, 30 to 40. All of a sudden it goes down again. So all of these things are going to have a mass amount of variability. The reality is, because these ranges are already so wide, 40 to 50, that's a 10-year gap, which is fine because you need to have something. So even a 10-year gap is totally fine. How we would normally determine the age of a skull like this is we would come up with a composite score. So every area of each suture, this area, this area, this area, these would all be given a score based on the amount of what we call obliteration, right? The amount of obliteration. So in one area, let's say the area that's closest to the coronal suture, we have no obliteration. We'll give that a score of 1. I'm just making this up. You go back to where it touches the lambdoidal suture, right? So let's say in that area we see this over here. give that a 2. Then we swing over and we start looking at the coronal suture and we give them all these scores. So every place along these sutures is given a score based on the degree of obliteration. Is it the first one, second one, third one, fourth one? We have a whole scale. This is just an image to give you a sense of what it would look like. This is not what we would use as our scale in the methods that we're going to use to determine the age of this individual. That's not the scale. That's just for demonstration purposes for you guys. Okay. So, but the point is we would create a composite score. So we would look at all these areas. We would look at the age range for each of those areas, give it a score, add up the score, and at the end we would say, okay, we have a score of 9, and we know based on our analysis on paper or in a computer, we know in an analysis that a score of 9 given these areas is somewhere between 50 and 65 years of age. We would say, okay, cool, that's what we have. Composite score of 9. 9 is associated with 50 to 65 or whatever I just said. That's what we listed at. So we don't look at single areas along a suture and just use that one time frame, because you can be grossly off, because this 30 to 40 down here, that's just a kind of general range that people fall into. Easily, that area right there can fuse as early as 20. It could fuse as late as 80. That's not made up. That's actually, those are true numbers. All right. So that part right there is crazy variable. So if you use just that area, you could be off by a mile when you age this individual. A composite score system is a lot better, because then it allows that extreme fluctuation when it comes to each of these areas. It kind of, I don't know, smooths those curves out, makes it so you don't have these giant spikes of 20 to 80, something like that. I mean, that's a giant spike, because that's grotesque. 20 to 80, I mean, that's a 60-year span where the person could be anywhere in there. So the composite score shrinks those extremes, right? And so that's a very good thing. I didn't put that on here. You can certainly, if you want, I'm highly doubting you're going to, but if you want, you can look online and look up composite score charts and all that kind of stuff. I didn't do it here because my screen is only so big, and I didn't want to just create a bunch of slides just for that purpose. You can always just look it up, but it doesn't matter. The point is, this is a method that can be used on the skull, as with dental attrition, but we're going to go with this one, right? This is a method that can be used, but by far, it's the worst method. Of the methods I've taught that I'm showing you, by far it's the worst. It's absolutely by far the worst. Is it the worst in general across the entire body? If we were to look at all elements, is it the worst? Yeah, I don't know. It could be. It could be, but there aren't that many things that you can use for the skull. If I get down below the skull, down in the postcranial, like I said, I can start throwing in osteoarthritis. I can start throwing in osteoporosis, or levels of, lower level of bone mineral density. That'll tell us age and stuff. So there's mineral densities we can do. A lot of different things we can do postcranially. There's not a whole lot you can do with the skull. It's very limited. So if we're dealing with the skull, this one isn't the worst thing you can ever, go after. It's not the worst by far. But if we're talking about the entire skeleton, it's not great. It really is not great. And that's just because the ranges are so broad. You're not going to get a real tight age on this individual. But that, we're not talking about a whole body. We're talking about a skull. And if we have nothing but a skull, we're going to have to rely on things like this. Dental attrition, suture closure. Neither is very good, but it's better than nothing, right? Okay, so like I said, I'm only doing a few things, so that's the last of our aging techniques. So you now have everything you need in your demographic profile. You learned about the sex of the individual, you learned about the ancestry of the individual, you learned about the age of the individual. There are other things that we would look at, that we would address in a real situation, like we talked about in class, like stature. How tall are they? Were they, between 5'5" and 5'8"? That's going to be very helpful in narrowing a database. There are things like that that we can use in this class, because we're almost done with the semester. We just don't have the time to do many of those things. So I'm going to stop it right here. But the demographic profile would also include stature. It would include, that's about as far as we'd go with what we call demographic profile, but we might also throw occupational markers, things like that, activity markers in general. We might throw that in there as well, just to kind of really put a fine point on who this individual might be. Then we go beyond that. So I'm not going to be able to go any further when it comes to that profile. We just don't have the time. But what we do need to talk about is trauma analysis, because we need to know, we know the person is dead. That's a given. They're sitting on the table, lying on the table in front of me. I know they're dead. Question is, how did they die? Can we say anything about that? Can we say that this was a death by natural cause, something like that? Death by way of gunshot, got stabbed, fell off a cliff, right? Something like that, was hit by a car, for gosh sake. So we have to look at those kinds of things so we can say, if possible, we can say something about how the situation occurred, what the event was that led to this individual's death. If it's just of natural causes or something, that's, it is what it is. That's how it works sometimes. But if it's foul play or something else that people need to know, this is something that is going to be important as we proceed. If we can give them any of this information, if we can help in any way, shape, or form to allow them to say, okay, you reported that there was this particular trauma. Could have been a broken bone, let's say, from, it's now healed, but not 100%. So we say, okay, this person broke their arm probably about a year ago. Hey, that's pretty good, because then when you narrow the database and you're going out, now law enforcement, they're going out and they're doing their job. They're trying to figure out who this person is. It's probably going to be helpful when you narrow it down to 3 kids or, something like that. It's pretty good that you'd be able to say, all right, we have these 3, ask the families of the 3, did they have a broken arm about a year ago? Hey, that's pretty good. That's really good. If they had some other traumatic injury or something, did they have that? Yes, they did. Boom, there you go. So trauma analysis is going to be crucial for our identification, but it's also going to be crucial in a criminal situation. Or sometimes, obviously there could be a situation where somebody died due to gunshot, but it wasn't foul play. The individual took their own life. So those are the kinds of things we're not going to be able to tease out. I mean, we're not going to be able to be crazy accurate in determining whether it was one way or the other, but what we can say is it was a gunshot. So that's at least a start to this process. So that's where we're going next. We're going to trauma analysis.